All right. Fluid pressure. So this is the first thing we're talking about. Fluids obviously means liquid gases. So, in a container, fluid pressure is caused by particles colliding with the walls of the container. So you have like an oxygen tank, like the old people wheel around with them, right? It's got compressed oxygen in there. The reason there's pressures is that oxygen, the little particles are banging against the edge of the container. Same thing when you blow up a balloon, those particles are banging the edge of the balloon, right? Imagine a balloon. The balloon only has a little tiny bit of pressure because it's not very strong. There's a balloon, right? And inside the balloon there's a whole bunch of particles, either atoms or molecules, depending on what's in there. Well, as these particles move around, there are collisions with the edge, right? And these collisions are what keep the edge of the balloon from collapsing upon itself. Now you might think to yourself, well, if these particles are colliding with the edge of the balloon and keeping it inflated, then why don't I see little bumps on the balloon over and over? Why don't you see a whole bunch of little bumps? They're so small and nope, there's too many of them. How many particles of air are inside of a balloon? Maybe 10 to the 24 or 10 to the 25, I mean, a ridiculous number, right? Like a trillion squared. So there's so many particles colliding with each edge of the balloon per second, you can't see it because it just looks like one constant force pushing outward. And same thing with any other container that has pressure inside. Okay, for this reason, pressure is equal in all parts of the container. What's your name? Tell me your drink. Okay, so let's suppose I take this, right, and I squeeze it. When I squeeze it, that means there's pressure inside the container. And let's say I squeeze it enough so that the pressure on this little square inch here is 50 pounds for that square inch, right? And so that would mean that on this square inch there's also 50 pounds. And on this square inch there's also 50 pounds. And the pressure everywhere is going to be 50 pounds per square inch. And on the lid and on the bottom, right? It's everywhere all at the same time. And if I squeeze it hard enough, wherever it's weakest and can least resist that pressure, that's where it's going to give, which usually is going to be the lid, right? All right, ready? Okay, so we can use this, right, to do a lot of things. For example, let's say we wanted to lift a really heavy object. We can build a device, and so I want you to draw this. It's going to be a long, thin tube. Imagine like a metal tube. Okay. There's a hole at the top. And inside this metal tube, there's a piston. It's going to look like a metal cylinder, basically. And let's say there's a handle on this thing going all the way out of the tube. It's a handle that you can grab onto and push down on. Okay. So this piston looks a lot like this. Just something you put inside the tube and you push liquid down into the tube, right? So something like that. All And then this thing is a big container full of liquid. Here's the rest of the container. Yep. And it's filled with some sort of liquid. And this liquid, I'll tell you what it is in a minute. Up to about here. And then on the other side, what I'm going to do is, I'm going to put a big fat piston, like something about this wide around, like this trash can lid, right? Because this big thing here is going to sit inside this one, so control the bigger piston. This one's just round and wide. Okay, let's say there's a handle on top of this, and maybe this thing can, can actually be used to lift things up, right? All right, so I have this closed system. I have it filled with liquid, and I can push down on either piston. So I'm going to push down on the piston in this tall, thin column. It's going to push liquid in, and when it pushes the liquid in, what's going to happen to this one? It's going to go up, right? It's going to push it up. Now, obviously, this is smaller. It's a thinner tube, so if I push this down 10 feet, this might go up 1 foot or 1 inch or something, depending on how big it is, because you've got to fill up all that much space. Okay, but here's the point. Let's assume that I'm standing up here. Here's me, right? I should put some hair on this guy, right? That's me. Okay, so I push down on this thing, right? I apply a force, and the force downward, we'll call it F1, because there's going to be 2 different forces in this problem. Well, if I'm pushing down with all my weight, then it would be basically my weight, right? I'm leaning on this thing. Let's say I weigh, I don't know, 4? All right, pick a number that's close to reality here.
120.
Let's go with 180. Let's say that's my weight. It's not. Anyway, so I apply a force downward of 180 pounds on my piston. So I'm pushing down on this piston, pushing the fluid into the thing, right? And then the area of this piston, right? Well, let's look at this one. This is pretty small. What's this? 1 square inch, 2 square inches, something like that. Let's call it 2 square inches, right? So let's say the area of this piston, I'm going to shade it in just to make sure you know what I'm talking about. It's the bottom part of the piston, but the top is going to be the same, right? That area there, that's what I'm measuring. So that area is going to be, let's say it's 2 inches squared. 2 inches squared. And I called it A1 because I also got to deal with the area of this piston in a minute, and that's going to be A2. Okay, so I'm pushing down on this piston, and the piston has a certain area. So can you tell me what the pressure inside here is going to be? Well, that's pretty simple, right? P equals F over A. So the pressure inside this system, and there's a liquid, so the pressure is going to be the same everywhere, actually even with a gas it would be, is going to be 180 pounds spread out over 2 square inches. What's half 180? Where got your calculators? 90. Pressure is 90 pounds per square inch. Okay. Now, if the pressure here is 90 pounds per square inch, what's the pressure here? 90 pounds per square inch. It's 90 pounds per square inch here, 90 pounds per square inch here. It's everywhere. The pressure, the force outward is 90 pounds per square inch. That means that that 90 pounds per square inch is also pushing up on this piston, right? Right. So, if I know the area of this piston, and I know the pressure inside this system, I could figure out the force pushing upward on this piston, can't I? So that should be pretty simple. So let's do that. Let's say this big piston, right? This is the big one inside of the big fat tube. So it's like this. It's being pushed up by the liquid on the bottom. Let's say it's the radius of this thing's like 10 inches, right? So pi r squared would be like 300 square inches or something like that. Let's call it 300 square inches. So that's this area here. Area 2 equals 300 square inches. And that's the area of the bottom of the piston. I'm showing you the top, but I don't have any other colors to use here. But basically the area of the top of that piston. Okay, so now if I want to find the force pushing up on this piston from the fluid, right, all I got to do is P equals F over A. So I multiply both sides by A. Area times pressure equals force. So it's going to be 300 square inches times the pressure inside the system, which is the same everywhere, 90 pounds per square inch. What's the force upward on that piston? 9 times 3 is 27, right? 27 with 3 zeros, 27,000 pounds. That's a lot, right? I mean, that could lift up a car. We need to put a car on here. Car. Let's see how it works now. Right. You could lift up a car just by pushing this piston down into this tank. And what is this whole thing called that I just drew for you? It's called a hydraulic jack. This is what happens when you go into your mechanic and they put your car on that lift and it lifts it up in the air. That's what this is. And you can lift it with your own hands. The only thing is, because this tube is so skinny, you'd have to push it really far down to make the car move really far up, right? So if you lift the car 10 feet, you'd probably have to push this piston down like 1,000 feet. Now in reality, there's no tube that's 1,000 feet tall with a 1,000-foot long piston to push all the way into there, so it would take forever. What do you do in real life? Instead of having a piston here, you just hook a pump up to it, a little hydraulic pump. But you could do this by hand yourself and lift your car up. It would just take a long time to lift it up. Questions? All right. On the worksheet today, I give you a couple problems where I give you something like this, a hydraulic jack. I tell you the force in the area of the little piston. You got to find the force up on the big piston. That'll be on the second page. You guys good to do that? All right. If not, I'll help you.
So we like to leave the videos.
What's that?
We can